This is another example of finding the area between two curves, concentrating on calculator keystrokes in order to accomplish this. The next example we're going to do here, our functions are 2 secant squared x and cosine of x, and we're interested in the area bounded by x is equal to negative pi over 4 on the left and positive pi over 4 on the right. Alright, I already have my calculator set up with the two functions in my y1, y2. And I already went over in the previous video why there's an advantage to typing them in y1 and y2 rather than in the home screen. Alright, so to type in 2 secant squared of x, we don't have a secant function on our calculator that we can directly type it in as it appears on the page. So we have to use the fact that secant is the reciprocal of cosine. So you have the 2, which is the coefficient in front, and then you have to type in secant as 1 over cosine, and that entire quantity gets squared. So that's one way, a safe way to type in 2 secant squared in your graphing calculator and have it produce the correct graph. The other y is just cosine of x. There's nothing interesting happening there. I'm going to go to my mode, make a quick check to make sure you're in radian mode. Unless we're told otherwise in this class, as it's always been, assume radians unless you're told otherwise. I'm going to do a zoom 7, which is a zoom trig, and I'm doing this to confirm that the graph I have on my calculator appears to be the same as the graph that they gave us. Okay, that's the check to make sure I typed it in correctly. Not a whole lot can go wrong with typing in cosine, but a couple things can go wrong with typing in the 2 secant squared. So it appears as though the graph looks pretty good. Now, when we do our subtraction, we want to make sure it's always top curve minus bottom curve. That's the way the formula works. Now, you may not know off the top of your head what 2 secant squared looks like, but you should absolutely know what cosine looks like. So cosine is the red curve here, which is the bottom one, and then the other one must be the 2 secant squared, which is the blue curve on my calculator. Alright, so I'm going to quit out of there. I'm in the home screen. I'm going to go to the math menu. I'm going to choose my FNINT. My lower bound is negative pi over 4. My upper bound is positive pi over 4. And the top curve is the secant squared, which is in y1. So I'm going to go to alpha f4, choose y1, minus alpha f4, y2, and we're integrating with respect to x. If you don't have the shortcut with the alpha f4, as a reminder, you have to go to var's function and then choose the correct one from there. Right, hit enter, and we get an answer of about 2.58-ish. Make sure that you follow whatever the rounding instructions are. As a side note with this, one of the disadvantages of doing this using technology is you're not going to get necessarily the exact answer. Most likely, if it's trig related and you get a decimal that looks like that, that's a decimal approximation for some radical expression. If we were to do this by hand with paper, pencil, calculus skills, we'd be able to get the exact value. For what we're trying to accomplish in this unit of our class, the decimal approximation is good enough for most problems. For this worksheet, it's good enough. For the quiz you'll take on this stuff, it'll be good enough.